is the same for Newton. Sigma F equal ma. The net forces is equal mass time acceleration. We can write also this in component form. In component form will be sigma F is a vector, the force is a vector, equal ma along x. The net forces along x is equal mass time the acceleration along x. Sigma F along y equal ma along y. The same will be along z in the third dimension. This is called the vector form of the Newton's second law, and this, which is the one that we will use frequently, will be the component form of the Newton's second law. Why the Newton's first law is a special case of the Newton's second law, you can see here. When the velocity is zero, or when is the velocity zero at all time, or the velocity, my bad, here there is a problem, constant, that was the same. If the velocity is zero or the velocity is constant, right? How much is the acceleration? Zero. Can you see that it's a special case? The Newton's first law is a special case of the second. So the second still work for the first. So if the acceleration is zero, it's because the velocity is zero or the velocity is constant. And definitely the net force will be how much? Zero. So this is a special case of this. This is the Newton's second law. From here, now we can find what will be the unit for force. So what will be the unit for force? The unit for force will be what? So, what is the mass? What is the unit for mass? Kilogram. So, if we have a force and we want to find the unit of measurement of the force, you can see that a force will be given in kilogram, that's the mass, times what? Meter over second square. When we multiply this is a derived unit, combined unit, that gives us what we call 1 Newton, which is equivalent to kilogram per meter, time meter per second square. This and this are equivalent. Kilogram time meter per second square is 1 Newton. So, in other words, what is 1 Newton? By definition, 1 Newton is the amount of force you need to move 1 kilogram at 1 meter per second square. So if I want to move 1 kilogram and give an acceleration of 1 meter per second square, when you combine those two things, that will be equivalent to 1 Newton. Any questions with the unit on what is 1 Newton? All right, good. Knowing that, this is the unit, 1 Newton. Now, let's find the first important force from here, from this equation, sigma F equal ma. We will look for very important force in nature on the surface of the earth, of course, which everybody said, the force of gravity, right? So imagine that I have an object here, like this. What is the only force acting on this when I am not holding? Now, the force of gravity, right? So, if the force of gravity is the only force, I can say that according to the Newton's second law, the force of gravity has to be equal to the net force. Is that right? The net force, the resultant, this is called net resultant, total, average. These are all the names that we give to the net force. Summation, addition, net, resultant,